So, can an AI actually learn the secret language of the sun? It sounds like something straight out of science fiction, right? Well, today we're going to find out if it's not just possible, but if it's already happening. I mean, just think about it for a second. What if this single biggest threat to all of our modern technology came from 93 million miles away? Because honestly, that's the reality we're living in. Our sun, the very star that gives us life, well, it also has this incredibly violent side that's a very real threat to our tech-dependent world. And that gets us right to the heart of the problem, a field of study called space weather. These are basically massive disturbances that get kicked off by the sun, and they can have some pretty major impacts right here at home. Yeah, we're talking about huge eruptions, things like solar flares and what are called coronal mass ejections or CMEs. Now, if one of those is pointed our way, bam, it can seriously mess with our satellites, it can destabilize entire power grids, and it can knock out the communication systems we rely on for, literally everything. So where do these solar temper tantrums even come from? Well, they all get cooked up in these incredibly complex and magnetically chaotic zones on the sun's surface. Scientists call them active regions, but a great way to think of them is as the sun's personal storm factories. So here's the deal. If we ever want to get good at predicting these storms, we have to learn how to read the warning signs. And all those clues are hidden deep inside the sun's super complex magnetic fields. The big question is, how on earth do you even do that? Well, scientists have a special tool for this. It's called a vector magnetogram. And honestly, the best way to picture it is like a super detailed weather map, but instead of tracking wind and rain, it's tracking the sun's magnetic forces. It tells you everything, not just where the magnetic fields are, but how strong they are and which way they're pointing. Okay, so how do you get from just a picture to some real usable insight? This is where the AI comes into play. It takes one of those magnetic weather maps as its input, and then it runs it through its complex model. What it spits out on the other side is the good stuff. 16 key numbers that basically describe everything important about that region's magnetic activity. And those 16 key metrics, they have a name, sharp parameters. I love this analogy. Think of them as the vital signs of an active region, just like a doctor checking your pulse and blood pressure. They measure it all, from the total magnetic energy to how much stress and twist is in those magnetic fields. In short, they tell us just how unstable an active region is and how likely it is to erupt. Now, as you can probably imagine, calculating all 16 of these vital signs for every single active region is just a monumental task for a human. It's slow, it's tedious. And that's what led researchers to this brilliant idea. What if we could just train an AI to do it for us? What if we could build an automated solar physicist? So how do you teach an AI to be a solar physicist? You give it a ton of homework, and I mean a ton. The AI was trained on a massive library of over 750,000 of these magnetic maps, collected over more than a decade. That is just an incredible amount of information for the AI to chew on and learn from. So what's under the hood of this thing? What does its brain actually look like? Well, it's a really clever hybrid design. And the best way to think about it is that it has a two-part brain, where each part is a specialist at a different kind of task. All right, so part one of the brain is a CNN. This is the detail spotter. It's fantastic at zooming in and finding all the little local features, like tiny, intense magnetic hotspots. Then you have part two, a SWIN transformer. This is the big picture thinker. Its job is to zoom out and understand the whole context, the large-scale patterns, and how everything fits together. You combine them and you get a really complete analysis. Okay, so the AI has done all its homework, it's gone through all that training. So how to do? It was time to give our new AI solar physicist its final exam. Did it pass the test? And the results were amazing. The AI scored an average of 0.934 in its predictions. Now, to put that in perspective, a perfect score would be 1.0. So getting over a 0.9 is wow. It's really, really good. It means the AI can read those solar vital signs with incredible accuracy. But, just like any report card, there's a little more to the story. It turns out the AI was an A-plus student on the big picture stuff, things related to the overall shape and large-scale twisting of the magnetic fields. But it had a harder time with the super fine-grained, noisy details, like calculating these tiny electric currents. That's the really tricky close-up work. And you can actually see this in the data. This grid shows you how well the AI did on all 16 parameters. See how some of these plots have a really tight, clean line of dots? That means a near-perfect prediction. Take a look at MANGM up in the top row. It's a beautiful straight line. Now compare that with mean JZD in the second row. See how the dots are way more scattered, kind of like a cloud? That's the visual proof of what it found easy and what it found hard. So this is all really cool science, but what does it actually mean for us back here on Earth? Well, this is way more than just a cool experiment. This research has serious, real-world implications for protecting all the technology we depend on every day. Really, what we're looking at here is a critical first step. It's a foundational building block. The ultimate goal, the big dream, is to build fully automated systems that are just watching the sun 24/7. Systems that can analyze these maps in real time and give us a much faster, more reliable heads-up when dangerous space weather is headed our way. All right, let's wrap this up. What are the big things you should take away from all this? First, and this is huge, an AI can learn to read the sun's complex magnetic maps, and with really high accuracy. Second, it's an absolute rock star at the big picture stuff, but it's still learning when it comes to the super fine-grained details. And finally, and this is the most important part, this work is a massive step forward, a key building block for the kind of automated alert systems that could one day protect all of us. I mean, when you step back, it's just a remarkable achievement. We've successfully taught a machine to understand the powerful, secret language of our own star. It really gets you thinking, doesn't it? If we can teach an AI to read the sun, what cosmic mystery should we teach it to solve next?